Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll review everything you need to know about linear relations. So there's three topics I'll go through: sketching graphs, gradient, and finding the equation of a line. So let's start with sketching graphs. So that's when you get an equation like this and you have to turn it into a graph. So the way we do that is always to start off with a table of values. So the table has two rows. Rows are going across. One is going to be for x values and one for y values. So what you do to fill out this table of values is you choose the x values. So I always tell my students you can always choose the x values from -2 to 2. So I didn't use any maths or calculations to come up with these, I just chose them. Now what we have to do is we have to take each x value one by one and find the corresponding y value. How do we do that? We substitute into this equation here. So when x equals -2, y equals 2 times -2 plus 1, which is -3. If x equals -1, y equals 2 times -1 plus 1, which is -1. If x equals 0, y equals 2 times 0 plus 1, which is 1. Now, in this section of the course, we're only looking at linear relations. When the relation is linear, there's always a pattern to what happens with the y value. Turns out the y value is going up by 2 each time. That's no coincidence. It's going up by 2 each time because this number in front of x is 2. As we will later see, this number is called the gradient. So to figure out the last two numbers that go here, I just follow the pattern of adding 2 each time. So it turns out this table of values actually gives us a set of points that lies on the line. Each of these columns going down, each of these columns is a point. This table gives me 5 points that lie on this line. The first point is -2, -3. So to plot that, I go across to x is -2, x is the horizontal axis, and I go down to y is -3, which is there. And similarly, I plot -1, -1 is here, 0, 1, so x is 0, y is 1 is there, x equals 1, y equals 3, x equals 2, y equals 5. You should see that the points all lie in a straight line. This is why it's called linear relations. When you graph something like this, you should get a straight line. So when you've plotted all of the points, you simply join them up with a line. You need to put arrows on each end because a line goes forever in both directions, and make sure you write the equation of the line on the line. Now, if the numbers on this Cartesian plane aren't given, you need to put them there because this line is only correct if it passes through these points. So we need to have our axes numbered. All right, let's now move on to gradient. So what is the gradient? Well, the gradient of a line is just a number, and it indicates how steep the line is. The higher the number, the steeper a line is. For some reason, we refer to the gradient as m. So if a line leans to the left, m is less than 0, that means the gradient is negative. If a line is perfectly horizontal, then the gradient is equal to 0, and if a line leans to the right, the gradient's greater than 0. Turns out, if you have a perfectly vertical line, there's no gradient. It's infinite or undefined. So if we look at all the lines here, the green line and the yellow line would both have a positive gradient. I know that because they're both leaning to the right. So the green line would have a higher gradient because it's steeper or more vertical than the yellow line. The black line is perfectly horizontal, so its gradient would be 0, and the red line is leaning to the left, so it would have a negative gradient. So let's look at how we actually calculate the gradient. There are actually a number of ways to calculate m, which is the gradient. So this means the change in y over the change in x, how much y changes divided by how much x changes, rise over the run, how far you go up or down, divided by how far you go right, and then this formula here. You can use either of them. What I'm going to do is calculate the gradient of the green line, black line, the gradient of the relationship in this table, and the gradient of the line passing through these 2 points. So let's start with this diagram here. So I'm going to start by calculating the gradient of the black line. Now, to calculate the gradient of any line, you need to have 2 points that are clearly visible. I'm going to choose these two because I can clearly see the coordinates. This is the point 1, 1. This is the point 2, 4. So what you do is you draw like a triangle. You always start at the point on the left and then you go to the other point. So let's look at how we get from this point to this point. So what we do is we go 1 to the right. So how far you go to the right is called the run. The run of this black line is 1. How far do I go up? Well, I go up from y equals 1 to y equals 4. I go up 1, 2, 3. So the rise of this black line is 3. So the gradient of the line is rise over the run. The gradient of this black line, rise is 3, run is 1. The gradient is just 3. The gradient's just a number to indicate how steep it is. Let's now calculate the gradient of the green line. So once again, I need 2 clearly visible points. So I'm going to pick this one here because I can see the coordinates here, 1, -1. I can see them really easily. And I'm going to pick this point here, the coordinates -1, 3, because I can see that really easy. So what you need to do is always start at the point on the left. So you're picking 2 points, always start at the one on the left and go to the one on the right. So to get from this point to this point, I've gone across 1, 2. So the run is 2 because I've gone 2 to the right. Now, what we're going to do is look at the rise. So to go from this point to this point, I've actually gone down. I've gone down 1, 2, 3, 4 units. So the rise is actually not 4, it's -4. The reason the rise is negative is because I went down. So the gradient of this green line is rise over run. So -4 divided by 2 is -2. The gradient of the green line is -2. So the green line has a negative gradient because it leans left, and the black line has a positive gradient because it leans right. So let's look at how we'd find the gradient of the relationship between x and y from this table. So we've got to look at what happens to x and y each time. Well, each time I go up by 2. X is increasing by 2. When x increases by 2, each time y is going up by 8. Now, because we're only dealing with linear relationships, the pattern for y's will always be the same. It won't go up by 8 and then up by 6 and up by 5. It'll always go up or down by the same amount. That's what makes the relationship linear. So this is the formula here we're going to use. The gradient here is the change in y. So each time we're adding 8 to y, divided by the change in x. And +8 divided by +2 is 4. The gradient here is 4. That means if x were to go up by just 1, y would go up by 4. So how do we find the gradient when we've got 2 points? Well, we can use either of these formula because they're all the same. So remember, in any point, it's always the x coordinate that comes first, y coordinate second. So let's do what we did with the table. Let's figure out what happened to y and what happened to x. So the y value's gone from 3 to 12. The change in y is +9. We've added 9 to the y value. For the x value, we've gone from -2 to 1. We've added 3. So the gradient here is change in y, 9, divided by change in x, which is 3. So 9 divided by 3 equals 3. If I were to draw a line that went through this point and this point, its gradient would be 3. So here, 9 is the rise, the change in y values is the rise, and the change in x values is the run. But now I'm going to do this one showing you how to use this, which is called the 2-point formula. It really doesn't matter which of these you use to calculate the gradient as long as you get the right answer. So if I use this formula, it's got, x1, y2, and all that. So x1 is the x-coordinate of the first point, x2 the x-coordinate of the second point, and similarly for y's. So if I want to calculate the gradient here, it's y2 minus y1 over x2 minus x1. So negative 2 minus 2 is negative 4 on top. 3 subtract negative 3 becomes 3 plus 3, 6, and that just simplifies to negative 2 over 3. The gradient here is negative 2 over 3. The gradient doesn't need to be a whole number. It can be a fraction or a decimal. So here the gradient, we had negative 4 over 6. Negative 4 because we went down by 4, we subtracted 4 from the y values, and we added 6 to the y values. That's why there's a 6 on the bottom. All right, let's now look at taking this one step further and finding the equation of a line. So the equation of any line can be written as y equals mx plus b, where m is the gradient and b is the y-intercept. So if you want to find the equation of a line, you just need to find its gradient and its y-intercept. So let's find the equation of the line in this diagram here. So our first step is we need to find the gradient. We're going to do that exactly as I showed you on a previous slide. So you need to pick 2 points you can clearly see. So you could pick this point here and this point here. Always start at the point on the left and go right. So I'm going to go across and then up to get to this point. So how far have I gone across? I've gone 4 to the right, so the run is 4. How far have I gone up? Well, I've gone up 1, 2. The y value's gone from negative 2 to 0. So the rise is 2. It's positive 2. The rise is positive because I went up. The rise would have been negative if I went down. So the gradient of this line is rise over run, 2 over 4, which simplifies to a half. Remember I said the gradient need not be a whole number. So that's m. Now b is the y-intercept. It is the point on the y, the vertical axis, the line passes through. The y-intercept here is negative 2. So the equation of this line is just y equals gradient x plus y-intercept. If I was started with this equation and graphed it, it would look like this. So how do we find the equation from a table? We use the same steps. Step 1 is to calculate the gradient. So in this table, x is going up by 1 each time. Y, we're subtracting 1 each time. It's going down by 1. So the gradient of this relationship is change in y over change in x. Negative 1 over 1 is negative 1. So how do I find the y-intercept from a table? Well, see, the thing is, the y-axis, all along here, the x-coordinate is 0. This is the point 0 minus 4. This is the point x equals 0, y equals negative 3. X equals 0, y equals negative 2. So the y-intercept is just the y value when x equals 0. If I were to plot these points, they'd lie in a straight line. The y-intercept would be 5. How did I know it was 5? Because that's the y value when x equals 0. So the point x equals 0, y equals 5 is here. If I were to graph this line, it would go through this point like that. So in this case, b is 5. So the equation is y equals gradient times x plus y-intercept. So think of this equation as a rule. It's a rule that tells you how to get the y value if you know the x value. So, for example, if x is negative 1 times negative 1 plus 5 is 6. Negative 1 times 0 plus 5 gives you the y value of 5. If I substitute x is 1, I get y equals negative 1 times 1 plus 5, which is 4. This is an equation, tells you how to get the y value if you know the x value. So let's do this one here, which is a little more complicated, because in this one, x isn't going up by 1 each time, it's going up by 3. Y, on the other hand, is going up by 9. We're adding 9 each time. So the gradient here is change in y divided by the change in x. 9 divided by 3 is 3. The gradient here is 3. So what would be the y-intercept? Well, this is a bit tricky because I told you the y-intercept is the y value when x equals 0. But here I don't have x equals 0. So we're going to put it on the table. What would y be when x equals 0? Well, let's go back to the gradient. Think about what this is saying. This is saying if x were to go up by 1, y would go up by 3. That's what the gradient means. So if I go up from -1 to 0, if I add 1 to the x value here, I need to add 3 to the y value. If the gradient was 4, I'd add 4 to the y value. But because the gradient's 3, I add 3 to the y value. So if I add 3 to this y value, of course, I get 7 plus 3, which is 10. So here, the y value when x equals 0 is 10. So B, the y-intercept is 10. So the equation is therefore y equals mx plus b. So if I were to graph this line, it would go through all of these points here. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.